At the reaction tank we have the dosing of sulfuric acid, aluminium sulfate and flocculant, and then these flocks with the pH of 6.4, 6.5 in the filter, going through the filter. The speed of filtration is about 1.8 meters per hour, and that means it takes nearly an hour to go through the filter for the water. Then we have a clear water, but there is the iron and the manganese inside as solved particle. No, not solved particles. No, as solved stuff. Then we add the lime water to have here the pH of 9.0, and then we have the autocatalytic demanganization inside here. Also, because it's all symmetric, it's the same size, we have the same speed here of filtration. And at the end we have the chlorine gas for disinfection. And so here you have the dosing amounts at sulfuric acid. It's not very much. I think today it's 2 grams per cubic meter. And quite important, the chlorine gas, 0.2 grams per cubic meters, not much. So normally you wouldn't smell it, even here in the water would not. And from here it takes about, it depends, 12 to 24 hours to our customers. So this is the time enough. So chlorine gas would be removed. Yes. Okay, so we have a short look in the. It's very cold. During the whole year we have the same temperature. Well, it's the temperature of the water. And in winter sometimes it's 8 degrees, and in summer maybe 12. So this is filter number 1 and number 2 of waterwork number 1. And you can see the sand starts at about 80 centimeters, maybe 1 meter. There the sand starts. Then we have 1.8 meters of sand, and the water coming from the right hand side on the filter, and you can see there are some parts in there. There's a little bit wood or something. Well, maybe some animals, I don't know.
No, just
it's not
waste
animals,
particles.
Okay, and you can see this the turbidity and the small flocks. You can even see and recognize the small flocks, I think, because it's in Germany we call it grizzly. It's very small.
Very small, yeah.
So the backwashing is, I think, today every 6 hours is the next filter. 60 hours of operation.
Is it backwashing today?
And then we have the backwashing.
Okay.
So we have one filter which is next, and the next one is just the backwashing is just done. So we have I don't know when the next filter has to be backwashing. Not all at the same time, but one after the other.
How deep is this filter?
Huh?
How deep is this filter?
Well,
I mean the water level. How much the water level normally rest on the top of sand?
It's about 4 meters.
Okay,
from
4.
4 meters.
4 meter down.
Yes.
Then we have sand, yeah?
No, 1 meter. As you can see over there, you can see the sand starts at about 1 meter.
Okay. Then the 3 meter we have sand, yeah?
1.8. So we have nearly 4 meters.
Nearly 4 meter. Okay. Okay. So these are all sand filtration. So long sand water is coming from here, and it passes the barrier, and it goes to the sand. The sand layer is nearly 3 meter, and it starts from 1 meter. It means the depth of water is 1 meter.
Turbulence and breaking it up, and then air and water about 8 minutes, I think, and then afterwards only water to wash it out. All in all, it's 20 minutes.
And after some years, don't you have to
do a specific cleaning like?
No, we never. No,
Only this?
only this.
Just backwash.
Yes, just backwashing.
Okay.
And we have our colleagues from the central laboratory, and they watch out for that, and they just control that, and look for the hygienes.
Hygienes. Yeah.
Thank you. And for all that stuff, so they test the grain of the sand and all that. So they give us the steps for the backwashing. So they say, okay, you have to do it 3 minutes, then 8 minutes, then 5 minutes.
How do they calculate it? Is there like
They're testing.
complicated
They're testing. Over there we have something for testing. This is these are 2 filters, and they just they measure several parameters, and then they say, okay, today we have this quality. Well, it's not different from one day to another. It takes time, you know. But they're watching out for that. That's their main thing to do. Okay. So the next step would be over there, when the temperature outside is about -20. But the water has a temperature of 8 degrees, and that's enough. So there's no ice cooking, no ice at all. There's no problem at all.
But if there were no ceiling, the water would get ice, right? If there was no ceiling, it was
Yes.
not a concern.
Yes, it would be ice. Yes. Okay, here we have a schedule. Well, in Harz Mountains, in the catchment area of our dams, of our reservoirs, we have some cities. Well, the bigger one is Klaustadt-Zellerfeld. There's also a university for the diggers, you know, people who are digging.
Mining.
Mining.
All the diggers. Okay, and some other small towns here with tourists also. Well, not so much, but there's sewage water, wastewater, out of households. We don't have any industry. We just have a little bit agriculture, not very much. So the wastewater, well, we don't want to have it in our reservoirs. So Harzwasserwerke started even in the 1970s to build pipes where we can collect all this household wastewater and give it around our reservoirs to the next sewage plant. For example, here at Oker, we have Altenau, and there's a pumping station and a pipe going down the valley of Oker to the next Klärnagel sewage plant, sewage treatment plant. And also the long one here through the Inester and here, so it's very important. So there's no wastewater in our village. This is the best safety and quality controlling for our water. Well, it makes the treatment easier. Okay. Here we are at the, well, we call it the pipeway for the first filtration step. The big pipes you can see here are for the first filtration. And here through the windows you can see the second filtration step. And this is the demanganization. As you can see, it's black. And,
Demanganization, and the water color is black.
yeah, and it's because of color, yes. Okay, so you can see these pipes here, and they were built in 1970, 72 maybe. And the color on the outside was never renewed since then. And this is possible, we made it possible because of having no corrosion here. As you feel, there's no humidity. Is that right? Humidity. Because we have air drying. These boxes, we dry the air inside here, so there's no water in the air. And there's no chance to have the water on the outside of the pipes because of temperature. And so we have the the outside for 40 years. Why-
That's quite amazing.
This is quite, yes. Why are No, I just made also like I mean, those windows are also filtered. Yes. And they're working. Yes. Okay. To see. No. Okay. No, they're all working. They're all working. Yes, sir. This is especially there's no water around here because of this drying, and this saves us money. Well, it costs money, yes, the electricity for this to dry the air, but for 40 years we don't have to fix the pipes.
How many of you have?
Well,
How many of you?
I think in all it's
How many
like
of these you
30.
have? 30
But, yes, but at different
places, yeah?
places, and it depends when my colleagues are working somewhere, maybe fixing a valve, then there's water. And then they just collect 2 or 3 extra ones to put it there to dry the water out.
Okay.
Well, we started with renewing some of the pipes, as you can see here, the blue ones, because the color, well, the architect who designed this, he said, well, the raw water has to be green, and the sludge water has to be yellow, and the air has to be red, but now we don't do this anymore. Every pipe would be blue. That's all. And here we have the pipe, a normal steel pipe, and the inside protection is a concrete. There's this, well, it's about thickness of 10 millimeters, I would say, concrete inside. And the outside is just a color. And nowadays we do a different system. We have a, it's a coat. As you can see here, for example. There's a special coat on it. And it's a kind of plastic. And so it's the thickness of half a millimeter. And it's something like you have in your fridge, you know, these layers inside. It's nearly the same. It's a pulver, and the pipe would be heated at about 300 degrees, and then given in a pulver. And this pulver smelts on the outside and gives this coat. And all the blue ones are like this, and it would last 30, 40, 50 years. And it's quite good, yes. This is the way we do it. Well, and as you can see, this one was built when the water one was built. To renew it would mean to cut it through and give new parts inside. But it's not necessary.
چون اگه کامپوزیشن دیفرنس داشته باشه داستان فکر نمی کنم چون فقط یه لاین بوده و پیش کرده
Well, it's getting cold now.
Piece of pipe laminated with the kind of plastic layer. So here you have. So we are going out of this system.